Today we're going to cover section 2.4 of our BJU Press Pre-Calculus textbook. We're going to have a look at polynomial functions. So we're going to identify polynomials, find their degrees, evaluate them, perform operations with them, and then talk about finding the zeros of them. So what is a polynomial? A polynomial is a mathematical expression consisting of terms, right? So a term is a product of a constant, which is like a number, and one or more variables raised to a non-negative integral power. So in a polynomial containing a single variable, the highest power of the variable is the degree of the polynomial. So if you have a polynomial with degree 1, you have a linear. A degree 2 is quadratic. A cubic is degree 3. You have a degree 4, which is a quartic, and then a quintic, which is degree 5. And these are the general equations of those first 5 degrees. Polynomials in one variable are usually written in descending order, with the highest power of x appearing first. The coefficient of that highest power is what we call the leading coefficient. And the very last term, which is just the number or the constant term, we call that A naught. And that's what that little zero after the A. It's the A naught term, and it always appears last, and it's just the number that does not have a variable on it. The constant polynomials, the degree of a constant polynomial, because it does not have a variable, it has no variables. So because of that, the degree has a 0, because if you think about it, if I have x to the 0 power, well, x to the 0 power is 1, which means that I just have whatever my coefficient was. I have no variable because my variable is almost kind of disappeared when I put it to the 0 power or the 0 degree. So the 0 power of the variable makes the degree 0, and it makes it just that constant number. There's only one exception to that rule, and it's the 0 polynomial when that is y equals 0, right? Because since 0 x to the n is equal to 0, no matter what n is, we can't really see what power n could have been. Let's do a practice problem. Let's do 4x plus 3x squared minus 4x minus 2x to the fourth in descending order. So descending order is highest to lowest. So the first term we want to put is the negative 2x to the fourth. Notice that the negative goes with that coefficient. The next is the 3x squared, then the 4x, and then the negative 4. Notice that the minus went with that term. What is the degree of the polynomial? Well, the highest term is 4, so we have a degree 4, which makes it a quintic. And what is the leading coefficient? Remember, the leading coefficient is that constant in front of the leading term. And so since x to the fourth is the highest degree, the constant in front of that is our leading coefficient, so that is negative 2. What is the constant term of our polynomial? Remember, the constant term is the one that appears last that does not have a variable appearing, and that would be negative 4. Notice that the negative goes with the term. What is the coefficient of the x cubed term? So as you can see, there is no x cubed term, which means that the coefficient in front of x cubed must have had been 0, because 0 times x cubed is just 0. So the coefficient in front of the x cubed term, since it's not appearing, would be 0. Let's say we want to find p of 2. So this is like p of 2 is kind of like saying f of 2, but instead of using f of x, we're going to use p of x, because we have polynomials. So polynomials usually don't say f of x equals, they usually say p of x equals. So when they say p of 2, it's just saying like find f of 2, like plug in 2 for x. So we're going to plug in 2 for x. And then we're going to evaluate. So remember, we have to do exponents first, which is what I did here on this line. And then once I do my exponents, then I can multiply, and then I can subtract. So let's go ahead and look at this example together. We want to answer the following. We have the polynomial 5x minus 7x squared minus 9 plus 8x to the fourth. We want to write in descending order. So the x to the fourth term comes first, then the x squared term, then the x term, and then the constant. So the x to the fourth term came first, and that term has a degree of 4, which means our polynomial is a degree 4. X to the fourth term came first. Its coefficient is 8, which means our leading coefficient is 8. Negative 9 is our constant term because it appears without a variable. And we want to know what are the coefficients of x cubed, x squared, and x. There is no x cubed, which means that the coefficient for x cubed was 0. The number appearing in front of x squared is negative 7. Remember, the negative goes with that term. And then the coefficient in front of x was 5. So let's do this practice. This is a multiple choice question. So it's either options 1, 2, 3, or 4. The answer isn't there. Let's look at this polynomial, 7 minus 2x cubed plus 4x minus 5x squared. Go ahead and try to write that in descending order and select the answer. So it's none of these, and the reason why is because negative 2x cubed had to appear first, because the negative goes with the term. The negative goes with the term, and none of our choices had a negative in front of the 2x cubed. Let's look at the definition of polynomial function. So again, instead of saying f of x, we have p of x to stand for the polynomial. And what it looks like is in descending order. So your degree or your exponent is always going to be 1 less. Always going to be 1 less until you get to your constant term where your n is 0, and that makes it x to the 0 power, which is 1, which gives you just a coefficient. In order for it to be a polynomial function, you had to have a positive n value or a positive degree. So let's look at these. These are terms that would make it to where you do not have a polynomial anymore. So the first one has a negative 2 of an exponent, and we said that our n value always, or our degree value always had to be positive. So that's why that's not a polynomial. The square root of x is the same as saying x to the 1/2. So that can't be a polynomial. 2 over x is the same as saying 2 times x to the negative 1 power, which again is not a polynomial. And then sine x is a trig function, and so it is also not a polynomial. All right, so example 2. Let's look at each of the following, A, B, and C. These are 3 different questions. We want to indicate whether it's a polynomial, and if it is, we want to give the degree. So let's look at A, 1/3 x squared plus 2/3 x plus 6. Now this is a polynomial because our fractions are our coefficients. They didn't give us fractions for our degrees, so it is still a polynomial, and so that means it's a degree 2, second degree. Next one is 7, which it is a polynomial. It's a constant, so it's it would be considered y equals 7, which means it has a 0 degree. The next one, C, is not a polynomial because of that -1 at the end. All right, let's say we want to find p of -1 if p of x is equal to 6x to the 5th plus 9x squared minus x plus 12. Look at the use of parentheses to help us figure out where the -1 is. Now we do exponents. -1 to the 5th, if I were to put that in my calculator, would be -1, and 6 times -1 becomes -6, and so on. And then you end up with p of -1 equals 16. Let's look at example 4. Example 4, we want to add p of x and q of x. So when we add, we want to just combine our like terms. So 6x cubed does not combine with anything. X squared combines with 3x squared, giving us 4x squared. -29x combines with -7x, giving us -36x. And then 8 combines with 3, giving us 11. Let's say we wanted to subtract them. Now, to subtract them, we have to distribute this negative to every term that comes after it. So instead of having 3x squared, we have minus 3x squared. Instead of having minus 7x, we have negative minus 7x, which becomes positive 7x. And then we have -3. Now we can combine like terms. 6x cubed doesn't combine with anything. X squared combines with -3x squared to give us -2x squared. -29x plus 7x is -22x. And then 8 minus 3 is 5. Let's look at p of x times q of x. There's a couple of ways to do this. If you had Algebra 2 with me last year, I would have shown you the box method. You can still use that method. You can also think of this as a distribution. First, we want to multiply everything in the second polynomial by 6x cubed. So 6x cubed times 3x squared is 18x to the 5th. 6x cubed times -7x is -42x to the 4th. 6x cubed times 3 is 18x cubed. Now we do our next term. X squared times 3x squared gives us 3x to the 4th. X squared times -7x gives us -7x cubed. X squared times 3 is 3x squared. Now our next term. -29x, notice the negative goes with the term, times 3x squared is -87x cubed. -29x times -7x is positive 203x squared. -29x plus 3 is -87x. Now our next term, which is at 8. 8 times 3x squared is 24x squared. 8 times -7x is -56x. And then 8 times 3 is 24. Now we add all of that together, and we end up with our final answer. Let's say we wanted to divide p of x divided by q of x. So this is where we start. What can I multiply 3x squared by to get 6x cubed? Well, I can multiply by 2x. So when I multiply by 2x, I'm going to multiply 3x squared, but I have to multiply every term afterwards. And I'm also subtracting because that's how we do our algorithm for long division. So 2x times 3x squared is 6x squared, but I'm going to subtract it. 2x times -7x is -14x squared, but I'm going to subtract it. So -14x squared subtracted is plus 14x squared. And then I have 2x times 3 is 6x, but I'm going to subtract it, and that gives me -6x. So I go ahead and combine all that. My 6x cubed and my -6x cubed cancels, which is what's supposed to happen. X squared plus 14x squared is 15x squared. -29x minus 6x is -35x. And then I go ahead and bring my 8 down. So then I think, what can I multiply by 3x squared to get 15x squared? Well, I can multiply by 5. 5 times 3x squared is 15x squared, but I'm going to subtract it. 5 times negative 7x is negative 35x, but I'm going to subtract it. Negative 35 subtracted is plus 35x. And then 5 times negative 3 is 15. 5 times 3 is 15, but I'm going to subtract it and get negative 15. So I combine those. My 15x squared cancels. My negative 35x also cancels. And then 8 minus 15 is negative 7. I don't have anything else to bring down. And there's nothing I can multiply 3x squared by to get negative 7, which means I have a remainder of negative 7. So this becomes my final answer. Let's talk about finding zeros of p of x. Okay, so in order to find a zero, you want to set your p of x equal to 0 and then factor. So we're going to let x squared plus 6x plus 24 equals 0, and then we're going to factor it. Since the polynomial cannot be factored, we have to use the quadratic formula to find the zeros. Remember, the quadratic formula is x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So let's go and try this one. So we set it equal to 0, and then we factor it. And when we factor it, we get 2x squared minus 11 and x squared minus 1. So we set those both equal to 0, and then we solve for x, and we end up with x is equal to plus or minus the square root of 11 over 2, and x is equal to plus or minus the square root of 1. And when we go ahead and simplify that radical, we get x is equal to plus or minus the square root of 22 over 2, and then the square root of 1 was 1, so we get x is equal to plus or minus 1. So the four zeros are 1 and negative 1. We have the square root of 22 over 2 and negative square root of 22 over 2. All right, that's it. Go ahead and try the problems.